Namaste and welcome back to the DSA class. Today we are going to be solving another really cool question which is commonly asked in most of these product-based company interviews, and the question goes something like this. You must reverse all the bits present within a 32-bit integer variable n. Now what does this mean? Very simple. Let us assume I'm just showing you a 32-bit integer variable like this. Now in binary it looks like this. In decimal, it is nothing but 101. So n is 101. Now you must not worry about all 32 bits, because please understand, whatever we will be doing for 32 bits, we can do for 8 bits also. And whatever works for 8 bits will work on 32 bits also, which means I'm removing all these extra bits and I'm only showing 8 bits. So 0, 11, 00, 101. Any confusion till here? Now you want to reverse all these bits. Now how would you reverse it? Let us assume I'll create another binary number below it, which is all zeros initially. Now ultimately that binary number should become the reversed version of the original. So how will I do it? Very simple, guys. I will have a pointer called as first, which will point to the first bit from the left. I will have a pointer called as L, which will point to the last bit, which is nothing but the first bit from the right. I hope you're able to think, right? So this is L, that is R. Now what I will do is, this is F and that is L. I hope I'm clear. Now, if in case I look at F, right, look at the bit. Is it set or unset? It is unset, right? It is 0. Now, if it is 0, then in the reversed bit, it must come in the first position. It must come in that first position. Now, in the first position, it's already 0. So, if it is unset, I don't have to do anything. I will keep it as it is, right? Now, I will look at L. I will look at the last bit. Now, if I look at the last bit L, clearly you can notice one thing, that L is set. L is set. If L is set, then in the first position of the reversed bit, I have to set it. But right now you can see it is unset. So I will set it. It will become 1. I hope you are able to see how reversing is happening. Then I will move F inside. I will also move L one step behind. I hope you're able to think. So F is one step behind, and one step forward, and L is one step behind. I hope you're able to think. Now what I will do is, again I will check. What is F pointing to? 1. 1 means it is set. Now in the reverse bit, it should come to the L position. It has to come to the L position. But look at it. It's 0, which means it's unset. So I have to set it. So it will become 1. Look at L. L is 0. L is 0. So it has to come where F is in the reversed bit. It is already 0. So I will not touch it. Again, I will move the pointers. If I move the pointers, F bit is set, which means at the L bit position in the reversed number, it has to be set. So I will set it. But if you look at L bit, obviously L bit is also set. So wherever F bit is, I have to set it. This way, if I continue, then you will notice at one point, F will become greater than L. See, F and L will cross each other. The moment they cross each other, already reversing has happened, and reversing has happened successfully. So the moment this happens, I will stop. Would you agree with me? Simple logic, simple logic. So if this can work on 8 bits, 100% it can be working on 32 bits as well, right? So how are we going to do this? Let me show you. Now listen to me and listen to me carefully. I have one setup ready here with me, okay? This is N, 101. That is reverse. Initially reverse is 0. As you can see, automatically F points to the first bit, which is at position 7 if count starts from 0. L is at the last bit, which is 0. And the same F and L, wherever F and L is pointing here, it will be pointing here as well. I hope you're able to think. Now, how will I start? My first duty is very simple. I want to check if in case the F bit in N is set, and that is what I'm also writing. Check if in case F bit in N is set. Now how will you check? Guys, I have already explained to you when we started bit manipulations as to how you can check whether a bit is set or not. And the rules are quite simple, quite straightforward. So I'm just showing it to you. Now if I want to check whether this bit is set or not, I need a mask. Now in the mask, it is going to be very simple. I will make this as 1, everything else I will make it as zeros like this. And what is the advantage? The advantage is if in case I were to perform AND operation, if this bit was set, I will get 1. If this bit was unset, I will get 0. And anyway, since everything else is 0, everything else will be 0, which means what should I be getting here? Because it is unset, I will get 0, 0, 0, 0, 0, 0, 0, 0. Everything is 0. Which means if you do AND operation between n and this mask, if you get everything as 0, it means that this bit was unset. If you would have got non-zero or not equal to 0, it means that this bit was set, because 1 and 1 would have been 1, and that is a non-zero number in decimal. I hope you're able to think. So now that English statement, I'm converting it into code. How will I check this? Very simple. I will check if in case n and I want this mask. Now how will I get this mask? Very simple. Look at this mask. This mask is nothing but 1 has to come wherever f bit is there. Rest everything else should be 0. So would you agree this is as simple as if in case I do something like this, I will do something like 1 left shifted by f times. I hope you're able to think. And I'm showing you this is 1. 1 is 0, 0, 0, 0, 0, 1. I hope you're able to think, right? Now if I left shifted by f times, what is the value of f? 7. If I left shifted by 7 times, 1 will come here. How are you able to think? And that is my mask. As simple as that. So wherever f is, if I left shift it f times, I will arrive there. As simple as that. So I did this. Now that's what I am also telling. If in case n and 1 left shifted by f times is not equal to 0, then what should you do? What you have to do is, you have to now in the reverse, this bit should become 0 here. In reverse, this bit should become 0. It is already 0. So I don't have to really do anything. But if it was not equal to 0, then I'll have to set the L bit. I have to set L bit in reverse. How to set the L bit in reverse we will see. But right now, because it is already 0, I don't have to touch it. Because it's already 0, I don't have to touch it, right? So here it is 0, here it is 0. Reversing is happening slowly. Great. Now your duty is to not only check F bit, your duty is to also check L bit. So now I will go to the L bit, okay? Now let me just quickly erase this for you. Okay. Now listen to me. Look at the L bit. L bit is set, right? I want to check whether it is set or not. Again, concept is very simple. Whenever you want to check whether a bit is set or not, the bit that you're checking with, make that as 1 in the mask, make everything else as zeros. Make everything else as zeros. If you make it as zeros, then what will happen? Do AND operation. 1 and 1 is 1. Everything else will become zeros. If that happens, tell me, in decimal, is this 0 or non-zero? In decimal, is this 0 or non-zero? 100% everybody would agree, sir, this is not equal to 0. So if it is not equal to 0, I know that the bit is set. So see here, I am just writing that. If in case n and, now this mask, how will you get? Very simple. Take 1, left shift it by L times. Here L was 0. So 1, if I left shift it 0 times, 1 will be here only. How you're able to think how to get this mask? That's it. Okay, so n and 1 left shifted by L times. If this is not equal to 0, then I know that the bit is set, L bit is set. If L bit is set, then in my reverse, the F position must be set. The F position must be set. Would you agree that is how reversing would happen? So now, how will I set this? So in my condition, I am telling, if it is not equal to 0, set F bit in reverse. Now, how are you going to set F bit in reverse? Very simple. You want to set this bit. How will you do it? Again, how to set a bit in the foundational lecture I have told you, right? All you have to do is make the bit you want to set as 1 in the mask and make everything else as zeros. And which operation if I do between these two bits will this become 1? It is nothing but OR operation. So what I will be doing is just a simple OR operation. It's just a simple OR operation. I want people to think. If I do that, what will happen is I will get 1 or 0 is 1, everything else will be as it is. Everything else will be as it is. Now that value is what I want to set back to reverse. I want to update reverse. So see, I'm changing it here only. Only one change you have to do, which is you have to make this as 1. Everything else anyways remains the same. So see, I've updated reverse, and decimal wise also reverse is changing. See, reverse has changed. Any confusion till this point of time? Amazing. What else, you may ask? What else if you ask me? This mask, how will you get, sir? Very simple, boss. This bit was set. So in reverse, wherever F is, that bit you had to set. So here if it is set, here it has to be set, correct? So how will you do this? Very simple. All you have to do is take 1, left shift it as many times such that 1 comes wherever F is pointing to. So would you agree? This is only my mask. This is only my mask. So if the L bit is set, the mask that you must apply to reverse to set that bit is nothing but 1 left shifted F times. I hope you're able to think. If it was F bit that you were setting and here L you have to sit, obviously you have to now make 1 left shift L number of times. Any confusion till here? Anyways, you have understood till this point of time. So that is what I am also showing there. I am removing the English statement and I am telling, hey listen, what you have to do is update reverse by telling reverse equal to reverse or 1 left shifted by F times. That is how you will set whatever was the L bit at the F position in reverse. Any confusion till this point of time? Yes, sir. Great. We understood. Now that you got the core concept, let me just erase this for you very quickly and let's quickly go to the next one. Okay. Now watch it, guys. Now I want to move it. I checked for F also. I checked for L also. Now I have to move these guys. So I'm just quickly going to move F by 1 position. I am going to move L by 1 position. So you can see this is F minus minus. This is L plus plus. Would you agree with me? And that is what I am also doing. See that? F minus minus L plus plus. So that they now what should happen? Now again I will check. Hey listen, this bit is set. If this bit is set, right? I want to check whether it is set or not. How will you check that? Very, very easy. I'm just removing all this for you. Now here if in case you check, all you have to do is you want to check whether this bit is set. Simple. Make that as 1. Make everything else as 0 in your mask. Perform AND operation. If you perform AND operation, if that bit is set, that will be 1, everything else will become zeros. I hope everybody is able to think, right? How to get this mask? Very simple. You want 1 to come wherever F is, which means take 1, left shift it F number of times. I think now everybody immediately has got an idea. Simple. Is this not equal to 0? Yes, it is not equal to 0, which means according to our condition, you must go inside and set the L bit. And of course, guys, please understand, whenever the pointers are moving here, the same pointers are here, they will move here also. So please understand, whatever is the position of F and L here will be the same position of F and L here as well. Any confusion? Now, because F bit is set, go to the L bit in reverse and set it. Go to the L bit and set it. Now, how will you set the L bit? Very simple. Reverse equal to reverse or 1, bring it wherever L is. So 1 left shifted L times. Would you agree? That is my mask. So very simple. If I have to show you my mask, everything will be 0. Wherever L is, there it should be 1. And if I apply OR operation and update my value of reverse, then all that will happen is this particular bit will now be set. Everything else remains the same. Slowly reversing is happening. Great. Quickly, let us now proceed. Okay. Now, next, again, I have now checked for my F bit. I have to now check for my L bit. Look at L bit. Is L bit set or not? How will you check? Very simple. Only one change. Make this as 0 because the mask 1 should be wherever L is pointing to. 1 should be wherever L is pointing to. And if you need this, then this should not be F, this should be L. Take 1, left shift it L number of times. So 1 will come here. Perform AND operation. Obviously, now this is going to be completely zeros. If this is going to be completely zeros, now you understood that, hey, yes, this is not set because it is equal to 0. If it is not set, then the F bit in reverse has to be 0. It is already 0, so no need to do anything. Only when it is 1, this setting operation is required. If it is 0, leave it as it is because we began by initializing reverse as 0. It was all zeros. So unset bits can be left as it is. Only set bits is what we have to work with. I hope you're able to think. Great. F and L is done. Now decrement F, increment L. So that's what I'm showing, right? F now gets decremented, L gets incremented. Whenever it changes there, please understand same F and L is here, so it changes here also. Now quickly start with F. It is set. To check if it is set, what must one do? Apply a mask where at the F position you have 1, everywhere else you have zeros. How will you get this mask? Very simple. Take 1, left shift it by F number of times. Upon doing this, obviously this bit is going to become 1. It is going to be non-zero. Non-zero means condition is true. If condition is true, you know at the Lth bit you have to set it. At the Lth bit you have to set it because if F bit is set here, if you reverse it, it will come at the Lth position. I hope you're able to think. How will you set this? Simple. To set it, you need a mask, and the mask is everywhere it should be 0. Only at the Lth bit it has to be 1. And if in case you do OR and update it, then you know this Lth bit is now going to become 1. I hope you're able to think. It's going to become 1. Slowly reversing is happening. Slowly reversing is happening. Great. Awesome. We have checked for the F bit. Look at the L bit. L bit is also 1. What is the mask you will apply to check if it is set or not? I think by now everybody has become experts, but still I'm going to just be explaining it to you. This has to become 1. Everything should be 0. And if in case you were to apply AND operation, everything else will be 0 except for the set bit, and because it is not equal to 0, condition is true. Since condition is true, you have to now set the F bit as 1 in the reverse. How will you do that? I think by now easily everybody has understood that you have to just go in the mask, everything else should be 0 except for the F bit. This will be 1, and since this is 1 and you perform OR operation and update it, this bit, my dear friends, is going to become 1. Everything remains the same. Everything remains the same. Beautiful. Now it is time for us to increment the pointers. So F is going to now move this way. L is now going to move this way. L is now going to move this way. Quickly I'm showing you. Look at this. F is also 0. L is also 0, right? Anyways, if you apply our operation, we'll also get the same result only. It is 0. So no need to do any setting. No need to do any setting because here also it is after all F and L, right? Here also it is F and L. So I'm just moving F this side, moving L this side. How are you able to think? Because it's 0, I've skipped it. I think everybody understood, right? Now, next time what will happen? F is going to again increment, friends. So I'm just putting it here. L is going to decrement. So see, F will come here, L will come here. Has F become greater than L? The moment F becomes greater than L, you must stop. You must stop. And ultimately, if you look at the reverse and you look at the original, 100% you can notice it has got reversed. See, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 0, 0, 1, 1. Reversed. As simple as that. Would you agree with me? So, on my logic, on my algorithm, I have to loop this. So how will I loop it? As long as F becomes greater than L, please do this. As long as F is greater than L, you keep doing this. Because see, greater, F became lesser than L. So you have to stop. Any confusion till here? That's it. So this is pretty much the algorithm for you to reverse your bits. Now, let us go write some code and see whether it actually works, right? Alright guys, let's begin coding. See, I represented N as 8 bits. When it was 8 bits, F was at the first bit, which was 7, and L was at the last bit, which was 0. But what if this became 32 bits? If it becomes 32 bits like this, then naturally f's initial value is not 7, it is 31. And L obviously is going to be 0 only. That's why I told you, whatever logic we did with respect to 8 bits can work for 16, 32 and 64 as well. I hope you're able to think. So, because our question explicitly told us that we have to work with integers, you know integers occupy 4 bytes in the memory, which is nothing but 32 bits. Since count starts from 0, the last bit is 31. I hope you're able to think. Anyways, I'll just remove this and I'm bringing the algorithm in front of me. Now let's just quickly code this algorithm. So I'll just go there and I will just tell int f equal to 31 and I will tell comma L is equal to 0. Okay, any confusion till here? Next I will come down and what I'm going to now do is simple. I will tell as long as f is greater than L. Because you know, ultimately, you know, f is here, L is here. Now they keep moving. One point they cross each other. F becomes smaller than L or L becomes greater than f. I hope you're able to think. That time we have to stop. So what I'm going to now do is very simple. If you look at my algorithm, first thing is to check if the f bit is set. If f bit is set, then you have to set the L bit in reverse. That's what we have to do. First of all, where is reverse? Let me just go there and create int reverse, and initially it is going to be 0. So see, I'm going to come down and I'll first check if f bit is set. So if in case, how will you check if a bit is set? Take the number n, do AND operation with a mask, and the mask should be at the bit you want to check whether it's set or not, and the bit you're checking whether it's set or not is the f bit. So how will you do it? 1 left shifted by f times. I've explained this to you. Check if it is not equal to 0. If it is not equal to 0, we know it is set. If it is set, come inside, and what we have to now do is we have to basically set the same bit in the reverse number, but at the last position, because in the original number if it has first position, in the next number it should come at the last position. Any confusion till here? So I will come here and I will just set my L bit in reverse. So how will you do this? Like this, I will reverse equal to reverse OR, right? Reverse OR, and at the L bit you have to do it. So I'll tell 1 left shifted by L times. So at the L bit position I will have 1. Great. Any confusion till here? So this is my updated value of reverse. Next I'll come outside the if. You checked if in case f bit is set and you set the L bit in reverse, but now you have to check if L bit is set and set the f bit in reverse. So that's what I'm doing. So if in case I'll tell n and 1 left shifted by L times. This is how you check whether in n the bit at L position is set. If so, not equal to 0, I'll check. That is when you know it's. If so, then in reverse I have to set the f bit, right? So as simple as that. So reverse is equal to reverse or 1 left shifted f times. So that's how you bring f1 to the f bit position and then do OR operation, it will become set. That's it. Now I'll come outside both the ifs. Now every time you loop you have to decrement f, increment L. That is what I'm doing. F minus minus and L plus plus. Now this will keep happening as long as f is ahead of L. The moment f goes behind L or f becomes greater than L, we stop. Any confusion till this point of time? Great. Let's start. So now if in case I have to obviously return the reverse, I will just tell return reverse like this. Any confusion till here? Great. Now let's just go and execute it and check it out, right? So if in case I go here and if I put, see we'll give a simple example. Let us assume I give 1 as my number. Now if I give 1, you know it is nothing but 0, 0, 0, 0, 0, 1. So 1 has to come, now 1 will come in the first bit. In the 32nd bit will become 1. So it should be a huge value. As you can see, it's such a huge value, and in fact it has, you know, wrapped at 1. If the MSB is 1, then you know it's a negative value and it is telling the range minus 214748368. This is the minimum number that you can store in an integer variable. So perfectly it works. This was the easiest way for me to demonstrate that 100% reverse has happened. Any confusion till this point of time? Great. Now I hope you enjoyed this program. And what would be the time complexity of this? Let me show you. Alright, now time complexity analysis is very simple. This is the binary number. See now every iteration, F moves, L moves. Next iteration, F moves, L moves. F moves, L moves. F moves, L moves, now F has crossed L, which means would you agree that only half the number of bits are being traversed, right? You look at F also, it is traversing only half, L also it is traversing only half, which means every iteration, since both are moving, would you say it is only going to take half the number of iterations, right? If full bits were traversed, it is big O of log n. If only half bits are traversed, it's big O of log n divided by 2. In time complexity, constants are ignored, which means again it comes down to big O of log n, right? Anyways, I hope both the logic and the time complexity is clear to you. Let's catch up in the next class.